Hi guys, for today's lesson we're going to be dealing with parallel and perpendicular lines. Okay, so first up, what do I mean by just parallel lines? Well, I'm sure you guys have heard of or know what a parallel line is. They're pretty much lines that won't touch each other. But in this context, it's two or more lines that have the same gradient. So having the same gradient implies that they're going to be parallel. So that's the main idea to take away from this. So i.e. the coefficients of x are equal in the y equals mx plus c form, or the gradient intercept form. So this m, which is the symbol for gradient, if we can tell that two lines are parallel because this m will be the same, because that indicates that the gradients are the same. So if you look at these four lines here, they're definitely parallel. If you look at their equations, the number that's in front of x is the same for each of these equations. Each of them has a gradient of minus 1 over 2. So you can see that that's definitely the case, because each line kind of has this like rise of 1 and run of 2 happening. So it's 1 over 2. And it's downhill, so it's going to be negative. Okay, next up is perpendicular lines. So they are two lines that intersect at right angles. And this is the symbol for perpendicular lines. It's like an upside down T. So if you see that, you just think it's suggesting that two different lines are perpendicular. I.e., another way of saying that two lines are perpendicular is that two lines have the negative reciprocal gradient for each other. So, for example, that the first gradient multiplied by the gradient of the second line, they multiply to give negative 1. I don't want you to worry too much about this, but the idea is that our gradients are going to be the negative reciprocal. And what do I mean by the negative reciprocal? Well, let's do an example to help you out. So e.g., if a line has a gradient of negative 3, then a line that is perpendicular has a gradient of 1/3, which is the negative reciprocal of negative 3. How is that the negative reciprocal? Well, what we've done is we've taken our negative 3 and we've made it negative 3 over 1. I'm going to take the reciprocal of negative 3 over 1, and that becomes 1 over negative 3. I've just flipped it. And I want to take the negative of it as well, so I put a negative out the front. So you'll see here when we flip it, we get 1 over 3, and the two negatives here are going to cancel each other out to make a positive. So pretty much, I look at this negative 3 here, it's negative, and if I take the negative of a negative, it's going to be positive, and this flipped is definitely 1 over 3, so we're going to get positive 1 over 3. This diagram shows you what's happening here. So this sort of interval PQ, it has a gradient of negative 3. The reason is because it's 3 over 1, which is 3, and it's downhill, which suggests that it's going to be this negative 3 gradient. And this one going uphill, that's positive, and the rise over run is 1 over 3, so that's a gradient of 1/3. And you can see that these two lines with the negative reciprocal gradients, they intersect at right angles. They're going to be perpendicular. Okay, so let's do some example questions on this. So determine the equation of the line that is perpendicular to y equals 5 over 4 lots of x minus 2, and it passes through this point as well. So we've got enough information here to be able to figure out the exact equation that we want. So our final answer needs to be some sort of equation, y equals mx plus c, where we know the gradient and we know the y-intercept. Okay, so perpendicular to this line means that our gradient is going to be negative 4 over 5. The way that I got the desired gradient is I took the negative reciprocal of this line's gradient. It's in gradient intercept form, so we can see that the gradient is right here, the coefficient of x. Flipping 5 over 4, it becomes 4 over 5, and because it's positive, we make it negative. So that's our desired gradient. We can only do this when we have y as the subject. And we know that it passes through the point 0,5. So that means that our y-intercept is going to be this 5 right here. The reason I know this point is a y-intercept point is because our x is 0. So that means it lies on the y-axis. If that point was not 0, this wouldn't give us our y-intercept. We'd have to use other means. So because we know our y-intercept of 5 and we know our gradient of negative 4 over 5, we have our final equation. So we can just use the gradient intercept form, make sure your y is the subject, and your gradient goes before your x. Question 2, a bit trickier this one. Determine the equation of the line, so similar sort of question, that is parallel to this and passes through the point 5, 1. Now this is significantly harder because this is not in gradient intercept form, so we can't see the gradient right here. And this point is not a y-intercept, so we don't know our y-intercept point yet. Okay, so the strategy, how do we do this one? Well, we convert the given equation to y equals mx plus c form to find its gradient. And then we substitute the point that we're given and the found gradient to solve for the y-intercept, which is c. So those are the two kind of things that you need to do for this question. So let's figure out what our gradient is by converting it to y equals mx plus c form. We make y the subject. So when we go through that process, we get to y equals minus 3x plus 2. We move the x's and then we move this 2. And we can see here that our gradient becomes negative 3. So because our line is parallel, we're going to have the same gradient as this. Our gradient's also going to be minus 3. Okay, so next up, now that we know our gradient, we just need to find out what our c is as well, because that's the only two things we need to know, the two numbers that we need to know. Our x and y, we're going to leave in our answer. But to find out our c, we need to use the given point that they've provided us with. We can substitute this point into the equation, and we can use it to solve for what our c is. So in our point, we've got an x value with its corresponding y value. So when y is equal to 1, we know that our x has to be 5. And if we do this, it'll make a true equation here. So, and we also know that our m is negative 3 because we found this before. So it's important we have our gradient already. Okay, so solving this, we've got minus 3 times 5 is minus 15. And we add the minus 15 over to figure out what our c is, get c by itself. And we get that our y-intercept c is 16. So our final answer is y equals minus 3x plus 16. There's our correct gradient of minus 3. And there's our correct y-intercept of 16. Hope this helps you with the questions. Good luck.